Okay, in this video, we're going to look at how to solve equations that have variables in exponents. Okay, but before we do that, we need to look at some rules that are going to help us get through these problems. So some things you want to think about, and you'll see this as we do these. You want to get the terms with the same base, but maybe a variable in the exponent on one side of the equation. And then you want to look for ways to combine. So right here, we're going to review the ways that we combine. Okay, you guys know that if you have x cubed times x to the fifth, notice the bases are both x, that when we multiply those, we actually add the powers. So this becomes 3 plus 5, which is 8. That's true even when we have a base that's a number. So see, this is a base of 3 with a power of x, and this is a base of 3 with a power of 2x minus 1. Because these two bases are the same, and we are multiplying, I can actually add the bases, or add the powers. So I keep the base of 3, and I add the power x plus 2x minus 1. I'm adding this power to this power. And then, of course, we can simplify this, becomes 3, and then x plus 2x is 3x minus 1. So I can, as long as the bases are the same and we are multiplying, I add powers. Now, also, this was combining things, putting things together. I might want to look for ways to break things apart so that I can maybe factor out a greatest common factor. So look at this one. Notice that the bases are the same, but this is not multiplication, so I can't put these together. This is subtraction, and addition would work the same. So I want to leave this one, but using the rule we just looked at up here, I'm actually going to take this term and I'm going to break it apart. I can break this apart as 3 to the power of x times 3 to the power of negative 2. So this and then this separately. And the reason that's true, because if you look at it the way it is now, where the bases are the same, if I wanted to put this back together, this is multiplication, and so I would add powers. X plus negative 2 would give me x minus 2. So I can go forward and backwards using this rule. I can combine things and I could break things apart. At this point, since I've broken this apart, I now have a 3 to the power of x here and a 3 to the power of x here, and so I could take a 3 to the power of x out. When I take a 3 to the power of x out as a greatest common factor, I have 1 left here, because remember, if I multiply back in, I have to come out with what I had up here. So make sure you don't forget that this is a 1. But in this case, this 3 to the power of x came out, and what I had left was 3 to the power of negative 2. And then, of course, this doesn't have a variable involved, so I could just simplify that. So I would leave my 3 to the power of x, and then inside that, I would have 1 minus, and this will become 1/9, and so I would have 8/9. And so that's a way to simplify. Okay, so you need to be familiar with both of these. So let's look at an example. Again, here we have a 4 to a power of x, and we have a 4 to a power of x plus 1, and we are multiplying. Then we have the 7 over here. So notice how this is different from the basic exponential equations that we have done in class. Okay, I want to put these two together. So I'm going to have 4. Remember, if the bases are the same and it's multiplication, I add the powers. So I'm going to have x plus 1. Then I have equals 7. And of course, we're going to simplify. So this is going to become 2x plus 1 in my exponent. And then I have equals 7. Okay, and then it looks just like problems that we've done in class. And of course, there's a couple different methods you can use to solve this. I can take the natural log of both sides, or the regular log, log, doesn't matter. And now that allows me to take this out of my exponent and move it to the front. So that would be 2x plus 1 times the natural log of 4 equals the natural log of 7. And from here, you could distribute this in, but I'm going to go ahead and divide by the natural log of 4, which is going to give me 2x plus 1 equals natural log of 7 over natural log of 4. Now, you could go ahead and do this math in your calculator, and you could get the decimal and work with it there. I'm just going to wait until the end to type it in. So I'm going to subtract 1 from both sides. That's going to give me 2x equals natural log of 7 over natural log of 4 minus 1. And then, of course, I'd want to divide by the 2. So this right side is pretty ugly, and you can do it in stages or be very careful and type the whole thing in your calculator. But when you do all of this math right here, you're going to get 0.202, and that's my answer to 3 significant figures. You could store the full value in your calculator, plug back into this left side, and check. Okay? Let's look at one more of these. And notice again, I have a base to a power of x minus 1 and a base of 3 to a power of x. So these two have the same base, but they're not on the same side. So when that happens, I do want to move them to the same side. So I'm going to move this 3 to the power of x to my left. Okay, that's going to give me 3 to the power of x minus 1 minus 3 to the power of x equals negative 3. And this time we're using the other rule. Okay, this is subtraction. So I can't put these together like they are right now. I can't add the powers because it's not multiplication. But I can break this one apart. I can break that into 3 to the power of x times 3 to the power of negative 1. And so now, since this and this is the same, I can take that out as a greatest common factor. In this case, when I take that out, I am left with this 3 to the power of negative 1, or you could rewrite that as 1/3 because that's what that's going to be, minus, again, when I take it out of here, I have 1 left. Simplifying a little bit more, inside these parentheses here, I am going to have a negative 2/3. And then our goal is to get this by itself, so we're going to divide by negative 2/3 from both sides. And I'm going to have 3 to the power of x equals, when I do this math, this double negative is going to make a positive, and I'm going to have 9/2. And then again, it looks like the basic ones now that we've been doing in class. So you could write it from exponential form to logarithmic form, or you can just go ahead and take the log of both sides. ln or log doesn't matter. And I can now move this to the front and get it out of the exponent. And then I can divide by natural log of 3. So x is going to equal, in this case, 1.37. And again, you should always check your answers. Okay, we're going to look at one more type of problem on this video. So notice again, I have something that's similar, but I have 3 terms now. I have more going on. This is a 3 to the power of 2x, and this is a 3 to the power of x. So what we need to do is we need to see if we can write this one where I have a 3 to the power of x. And if I want to, I can say 3 to the power of x squared. Because remember, when you have something like this, when you have an exponent raised to another exponent, these two would get multiplied to be 2x, which is what we have. So I can break it apart like this. Okay, and then everything I have left is right here. And so at this point, this looks very similar. This almost looks quadratic, and it's going to look more quadratic if we choose to let y equal 3 to the power of x. So by substituting in y, it's going to look a lot more familiar to you. So y squared minus 7y plus 10 equals 0. And all I did was substitute a variable, I chose y, a variable into where I had 3 to the power of x. Now it's quadratic. Now we can solve like normal, so you factor or use quadratic formula. If you factor, you're going to get y minus 5, y minus 2 equals 0. When we solve this, we get y equals 5, y equals 2. You just have to remember at the end to go back to this because we want our answers in terms of x. We weren't given an equation that had a y in it, so we want to take our answers back based on this equation here. So everywhere I see y, I'm going to put 3 to the power of x. So I'm going to have 3 to the power of x equals 5, and 3 to the power of x equals 2. And of course now we're back to what we've seen before. So here I'm going to take the natural log of both sides. I'm going to move my x to the front. And then I'm just going to divide to get x by itself. This is calculator work. I get x equals 1.46. Same thing over here. Natural log of both sides. Move the x to the front. Divide so that x is by itself. And this one is going to give me 0.631. Again, always check your answers, but in this case, both of them work. Okay, let's look at another one like that. Again, remember I'm seeing that these are similar, but I want this first term here so that it has 2 to the power of x. So I can write 2 to the power of x squared because that's equivalent to this. Minus 6 times 2 to the power of x plus 5. Let y equal 2 to the power of x so that we can make it look quadratic. I'm going to plug the y in here. I get y squared. Plugging the y into my second term, I get 6y plus 5 equals 0. From here, you all know how to solve. So again, quadratic formula or factor. This is going to give me y minus 5 and y minus 1, which is going to give me y equals 5 and y equals positive 1. And then just don't forget at the end, you have to use this and you have to plug these values back into y. So I have 2 to the power of x equals 5 and 2 to the power of x equals 1. Again, solving the same way that I solved the others. Take the natural log of both sides, move your x to the front, and then divide so that you can get x by itself. Okay? X in this case is going to be equal to 2.32. Same thing over here. Now we should know that the natural log of 1 is 0, so I could actually go ahead and simplify that. And when I move my x to the front and divide by natural log of 2, 0 divided by anything is 0. So x equals 0 is my other value. Okay? All right, I want you to take a minute and try this problem, so pause the video, try it, and then check your answer with me. Okay, on this one again, I'm going to write 5 to the power of x squared instead of writing it as 5 to the power of 2x. I can do that because 2 times x is 2x. Minus 6 times 5 to the power of x minus 7. So now I'm going to let y, I want to let y equal 5 to the power of x, and then I'm going to substitute the y in. So I get y squared minus 6y minus 7 equals 0. I'm going to choose to factor. I get y minus 7, y plus 1, which gives me y equals 7 and y equals negative 1. Don't forget to go back and use this to solve for x. So I'm going to have 5 to the power of x equals 7 and 5 to the power of x equals negative 1. And so here I'm doing the same thing you've seen me do a lot now. I'm going to take this x to the front and I'm going to divide by natural log of 5 to get x by itself, which gives me x equals 1.21. Now on this one, when I take the natural log of both sides, what you're going to see hopefully immediately is that I have the natural log of a negative, and I can't do that. That's undefined. It's a domain error, so I can't solve this one. So in this case, this is my only answer. Okay, I want you to do the same thing here. Okay, so just pause the video and see if you can do this one. Try it. Okay, on this one, we're going to start the same way. Let's see what we can do. I know that I can write this first term as 3 to the power of x squared. But here, we have more in the exponent. But remember our rule? We can break this down. We can break this into 3 to the power of x times 3 to the power of 1. Okay, that was the rule we went over at the beginning. And then minus 10. And so now, if I let y equal 3 to the power of x, I'm going to have y squared. Now my y is going to go in place of this one, so I'd have y times 3. I'm just going to write the 3 first as my coefficient. So 3 times y minus 10. And now it looks just like the other ones we solved. And so when I factor this, I'm going to get y plus 5 and y minus 2. Okay, when I solve this one, I get y equals negative 5 and y equals positive 2. And I'm going to go back up and use this to solve for x. So I'm going to set 3 to the power of x equal to my negative 5 and 3 to the power of x equal to 2. And then I'm going to solve like you've seen me do now a lot. Take the natural log of both sides, and hopefully right now you realize this isn't going to work. Natural log of a negative is domain error, undefined, can't have the negative inside the log, so that one's out. And then I'm going to do natural log of 3 to the power of x equals natural log of 2, move my x to the front, and then divide by natural log of 3. When I do this, I'm going to get x equals 0.631, and that is my only answer for this problem. Okay, I will see you in class.